Our second type of rigid transformation are reflections. So we're going to take the same triangle, we're going to reflect it over the y-axis here. So the y-axis is this axis, the vertical axis, it's even labeled y, so I'm going to just draw it in blue to make it obvious which one we are reflecting over. There we go. So rather than reflecting the whole triangle, reflect it point by point. So how far, well, if I'm reflecting it over, I'm flipping it over here. How far away is A from the y-axis? It is 1, 2, 3, 4, 5. It's 6 units left, so I need to go 1, 2, 3, 4, 5, 6 units to the right. This is my A prime. B is 3 units left from the y-axis, so it's going to be 3 units right from the y-axis. B prime. C, 1, 2, 3, 4, 5. It's 5 to the left. If I'm flipping it over, it should be 5 to the right. And we're going to call this C prime. Connect my triangle. There we go. So this definitely looks like a reflection. It looks like it's been mirrored not vertically, mirrored horizontally. So let's make note of the coordinates. A is 6, 3. B prime is 3, 2. C prime is 5, negative 1. So notice the points are really, really similar. The only thing that's actually changed is the x values. The x values were all negative in A, B, and C. The x values are now all positive. So this is represented by the notation negative x, comma, y. Think about this. All the x values for each point have flipped over across the axis. So now they're all positive. So all negative x values change to positives. Remember, negative does not mean make it negative. It means that there is a sign change. So you change all the negatives to positives and positives to negatives. All right, now let's reflect this one over the x-axis. This one's going to look a little bit messy. So the x-axis is the horizontal one right here. A little bit of that. So A is 3 above the x-axis. It must go 3 below the x-axis. So this is A double prime. B is 2 above, so it should go 2 below. B double prime. C was 1 below, so C prime is going to go above. And in fact, C double prime. So these triangles seem to kind of clash into one another. So let's mark the points. A double prime, that is negative 6, negative 3. B double prime is negative 3, negative 2. Finally, C double prime, that's 1, 2, 3, 4, 5. 1, negative 5. And positive 1. So let's compare our new points with the originals. Let's use the vocabulary, the pre-image points with the image points. Well, this time the x values did not change. The y values did. Positive 3 changed to negative 3. Positive 2 changed to negative 2. And negative 1 changed to positive 1. So again, there is a sign change. So for my coordinate notation, x stayed the same, y has changed to negative. Because think about it. All your y values which are above went below. All the ones that are below went above. All right. And then finally, for our final reflection over the line y equals x. There are more, but these are the 3 main ones that you should be concerned with. So first, to reflect over the line y equals x, we need to draw it first. Remember, y equals x is the line where the x and y values are all the same. So that looks like a perfect diagonal line from the upper right side of the graph to the lower left. This is because along this line, all the x and y values are exactly the same. So why don't we erase the other ones just so we don't get so confused. And we can just focus on the reflection across y equals x. Right, just cleaning it up. All right, nice. So with y equals x, that is a diagonal line. So for reflecting it, it's best to think diagonally. So let's start with point A. How far away is point A from the line diagonally? It is 1, 2, 3, 4.5 diagonal distance from the line. So I would go half, 1, 2, 3, 4. You're going in the opposite direction of the line. So A, let's call this one triple prime. Let's do the same thing for B now. B, it's 1, 2.5. So half, 1, 2. B, triple prime. And for C, how far away is C from the line? It's 1, 2 from this line. So we're going to go 1, 2 diagonally here. All right, so let's mark this as C triple prime. And let's erase this. There you go. All right, connect the triangle, make it look nice. Well, if you're looking at it just vertically right now, it doesn't quite look right, but if you tilt your head so that the line y equals x looks vertical, it does appear more like a reflection. So let's mark the points and then think about the coordinate notation. So A prime, 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 triple prime is 3, negative 1, 2, 3, 4, 5, 6. 3, negative 6. All right, B triple prime ends up being 2, negative 3. And C triple prime is negative 1, 1, 2, 3, 4. Negative 1, negative 5. All right, let's compare the original points. Well, the x and y values have completely switched. X is now y, y is now x. So that is reflected in our coordinate notation. xy is changed to y, comma, x. So with reflection over the y-axis, x becomes negative. The x values become the opposite. For reflections over the x-axis, the y values become the opposite. X's don't change. But a reflection over the line y equals x, both the x and y values, they switch places. There are more reflections, but these are the three main ones you should care about.